All right, so now we're finally to the point where we can talk about underscore. So we talked about scope, we talked about how closures worked, we talked about the complexities between an parameter versus an argument, and how all these components work together. And now we can use a utility library like underscore JS, which combines all of these concepts into a handy library that gives us all these utility functions that allow us to do some pretty cool things. So the first thing is, has anyone used a library here? Like, raise your hand if you used a library before. Cool. So underscore is a library, which basically, a library in essence is just a collection of methods available to you. So we have a jQuery library, which provides us a function, a jQuery function, that looks like this, right? And we can call it like that. Underscore is a library that gives us an object that's an underscore with a bunch of different properties on it. So the syntax for underscore, you'll see an underscore and a dot. And you can just imagine that somewhere in the library it says underscore, it says var underscore equals some object. And that's why we use dot notation. And then we can say underscore dot, some method equals some function, and then, some function that does something. So that's like how it's working at its core, and we just include that JavaScript file in our HTML, and we have access to all those methods. And let's just check out the underscore library just to kind of get a feel of what it looks like. So this is just their documentation. You can see that underscore comes with all of these handy functions that you can use that make your code easier. The cool thing about underscore is it works in all environments. It's just pure JavaScript. It's not like jQuery where it only works in the browser. So you could use underscore, for example, in Node. It's used a lot, or in if you're doing some hardware stuff as well. Cool. And then you can also look at the annotated source code, which is really interesting. You can see like how they actually write underscore, and it's all annotated. So you could see like how reduce is written here. And let's see, at the very bottom. Yeah. So that's really handy if like you're getting stuck and you kind of want to see how it's really working underneath. Yep.
Did you say jQuery only works in the browser?
Yes. It's made for, if you think about it, jQuery is all about selecting DOM nodes and then manipulating them and then putting them back into the DOM. And the DOM is the browser, lives in the browser. Cool. So we're going to talk about a couple jQuery underscore methods, how to use them, and then I'm kind of going to set you loose and let you just explore and work with underscore on some exercise. So the first one that I want to talk about is each. The first, this is one of the most common underscore methods that's used. And you don't only have to it's not only used in functional programming. In fact, a lot of people use this. I want to argue that most people use each. Either in underscores each, jQuery has its own version of each, and then there's a native for each as well that comes with JavaScript. So what each does is that it takes a list. It could be an object or an array, and for every element in that array, it calls the callback function here. So now you guys can see what I was talking about with the value, the index, and the list, and from the exercises, is because that's how each works. So in this example, this function here is going to be called 3 times. The first time is going to be called with 1 as the value, and then 0 in the whole array. The second time, val is going to be 2, and the index is going to be what? What's the index going to be?
1.
1. And then the whole list, right, that array. And then the last time, the val is going to be 3, I is going to be 2, and again, the list is going to be the whole list. And we know from our prior discussions that we don't have to work with all the parameters, right? So this, in this signature here, this function signature, those are just parameter names. We don't have to reference all of them. So if we just wanted to console.log the val, that's fine. But if we wanted to do all of them, we could also do that too. And we also know that we could call this whatever we want, right? Sometimes it's called element. You can like spell it all out. Index. I don't know. You can call it whatever you want. And so as long as they match in the function body, that's what's important. So as far as the order of element, index, and the whole list, that order doesn't change. So it's always going to be the value, it's always going to be the index, and then it's always going to be the list in that order. That's the order of the parameters. So whatever you call it, call those parameters, it's still going to be passed in that order. So for example, let me just go back the way, it won't let me. So we had it like this before, val I and list, right? If we swapped val and I like that, I would then be val. So you can't mix these up. Or you can name them whatever you want, but it's not going to affect the value that it holds. So this first one is always going to be the value, and the second one is always going to be the index. Cool?
And it's just a quick way to kind of, instead of having a function that loops through a collection.
Yeah. And so this is awesome because you don't have to write out the loop the whole time. It's more obvious what it's doing, where your attention in loop syntax kind of is drawn to the mechanics of the loop, like where does it start, up until when, etc. And then also, each will work with both arrays and objects, so you don't have to worry about the for-in loop versus the for loop with the semicolons, and then or the length, or like, you know, having to do has own property and those kind of things. You don't have to worry about that with each, and it kind of just takes care of it for you, which is great. However, the native for each in JavaScript, I think, is only for arrays, so keep that in mind. But each and underscore can do both. Oops, my email's open. Yeah, so awesome. So let's look at it a little more. So we're gonna use each with this array, say my Pocketmon array with the Charsword, Bulbasaur, and 2mu. And we have this function logger. All logger does is it takes a value and it console.logs that value. And so how are we going to use each to log all the values of our Pocketmon? So we start with each like this. Let's see. William, do you know?
Your first parameter is the array, so Pocketmon.
Pocketmon, yep. And then the second one. Do you know, Grace? Logger, yeah. Yeah, so iterator is just a fancy word for the function that's going to be called every time in the loop. So yeah, and that's basically how we use each, is we pass it our array, and then each time the loop is called, it's going to call this logger function with, first it's going to say Charsword, then it's going to be Bulbasaur, and then it's going to be 2mu. So that's the order. Cool. Oh, and I wanted to introduce, remember Animal Maker from yesterday? We have this animal function, or this Animal Maker constructor function that creates our animals. So we had some animal names. Can someone give me some animal names?
Smokey.
Smokey.
Fluffy.
Fluffy.
Trigger.
Trigger. Okay. So what we want to do here is the same as yesterday, is we want to loop through all the animal names create an animal object that has the speak method on it, and then add them to our farm. And so this is how we did it with just a regular loop. We did a for loop, we started at 0, we looped until, or while I is less than animal names.length, and then we said I plus plus, right? We incremented I each time by 1. And then we are running each animal name, so Smoky, Fluffy, Trigger, one at a time into our animal maker function. So we see here that we're calling a function with the animal name at I, and then we're pushing that whole thing into our farm. And so my challenge to you is to take a couple minutes and rewrite this using each. Anyone know what the first argument we should pass to each should be?
Animal names?
Mm-hmm. Mm-hmm. And the second one's going to be a function, right? Let's move this up so we have more space. So what are we going to put inside the function?
Can you push?
So farm.push. What are we going to push? Andy, do you know we're going to push?
I think we're going to push name, right?
Close. We do need to use the name. But we need to make sure that we don't forget to pass it through our constructor function, animal maker. What about, Kim, do you have an idea of what we should add to this line?
Animal maker.
Mm-hmm. Like that? Yeah. Cool. And so now we can just delete this. Or actually, let's take a moment and sort of compare how these look, right? Like, you remember how I was saying that for our for loop, the attention is drawn more to the mechanics of the loop rather than what it's actually doing? You can see this pretty clearly here. Is that the mechanics of the loop actually takes a lot of typing, and that's not the important part. And it also leaves a lot of room for human error, like off by 1, or you put a comma instead of semicolon where you're supposed to. So with each, it really simplifies that, where you only have to pay attention to the data and then the function in which you want to run and the functionality.
So that in the underscore each part, where it says function parentheses name, that's referring to each of the objects in that animal names, or
Here?
just a placeholder.
Here?
Yeah.
Yeah,
so
that's
that
a
name,
placeholder.
This is a placeholder that represent each of the iterations
Yeah,
of animal names,
exactly. So it's val.
and then you'd have to put val down there.
Right, exactly.
It's got to be the same.
Yeah. And the cool thing about this is that we can say name, right? It's just more clear versus animal names at I.
Yeah.
It's less clear what that means. If we just say, oh, we call this name, then it's clear to me, oh, so we're making an animal, we're making an animal, we're passing in a name, and then we're adding it to the farm. So it's just more clear what you're doing, and you're able to do that naming here versus when we have a regular loop, we have to do all this bracket I stuff.
So the argument in the callback function refers to the index in the list, each index in the list.
Yeah, so the parameter here could be, is going to be, the first one's going to be Smoky,
Right.
and you can also put the index here, and you can also put the whole list. But since we're not really using it, we don't need to do that, but you could.
So every time it loops, then name will go Smoky, Fluffy, Trigger.
Yes. Yep.
What if animal names, that array, instead of just having a string in each area or each spot, what if it was an object with, you know what I'm saying? What if it was a more complex object? How would each know what to pick out of there and send it back?
Yeah, so there's a few ways you can deal with that. So you can say, you can call this, then this would be like animal. You call it animal obj in case you forget that it's an object. And then you can actually just nest your each like this. And this would loop through your animal object. And then in this function, you can do whatever you want it to do with it. So this would be like so then you could nest your each statement like that.
So in that case, when you pass in an object, first argument is going to be the property name, and then the second argument is going to be the value.
No, it's going to be the value, and then the property name, and then the animal object. Yeah. So where for an array it would be the index, for an object it would just be the property name itself. And again, if you were nesting regular for loops, then you start to have things like, you know, you'd probably have a j in there, and it gets really complicated here. If, like, for example, this is like, I can't even think about what it could be like.
Height, weight, whatever. No.
Yeah, you can call it like characteristics. Characteristics. Or we'll just call it char for short. And then you would just, it's easy to see that we're going to like, now we're console logging all the characteristics of our animal object versus something at ij, you know. Cool. So awesome. So we're pushing our animal. Now what if we wanted to then, actually, do I have that one? Okay. Cool. So any questions about this? Pretty straightforward. Awesome. So another one that we use a lot is map. And map and each have a lot in common. The important thing to note about each is that you can't return anything from each. So if we see here, we're pushing to our farm, but we're not using a return statement. You cannot use a return statement in this function. It won't work. So just keep that in mind. However, in map, it's really important what you return. So map does the same thing where it's going to loop through an object or an array, and it's going to apply it to a function. The difference here is what we return. So if we return here, we return some value here, that's going to be placed into an array. And so we have to save this in a variable. And so nums would then be, again, just an array of numbers. So it would return that. So whatever is returned from the callback is going to be put into an array. So we can return like num, the value plus 1, and then that would output 2, 3, 4. So then you can transform your data this way. So it produces a new array of values by mapping each value in the list and transforming it using this function. And the same holds true with the parameters. They're always going to be the value, the index, and the entire list. Cool. So back to our our Pocketmon example. We have an array of Pocketmons, and then we have a function called excited array. And this is my algorithm that takes any string and suddenly makes it an exciting string. So how do we use this using map? So of course we'd say _.map. And what do we pass it? How about Tanner?
Pass it a 1, 2, 3 in the brackets. Or no, I'm sorry.
Yeah, you're one side of mine.
We pass it the function Pokemon.
Yeah, so we pass it Pokemon, which is an array
Am I right?
of our Pocketmons. Should it be Pocketmons or Pocketmon? What do you think?
Pocketmon
Pocketmon for plural, so it's like sheep, sheep. Okay.
or deer.
Or deer, yeah. Cool. And then what do we pass?
So,
What about William? You've been quiet.
Pass it the callback function you want to call for each one of them. So I think it's excited ARR.
Yep. There's no other functions on the page. And so we just pass excited AR. Notice we're not calling it here. We're simply passing it. That's important. Cool.
Well,
Should
so
we
how does
test
it
it?
know that it's going to use the value? Because when you're defining excited or R, it's just using val.
Yeah, so that's just a parameter. We can call this like string too.
I know, but maybe
The mechanics of map, how it works, is that the first thing it calls the function with, whatever function it is, whether or not it has parameters or not, it's going to call excited array like this. With first, so if we're just doing this example, it would be Pocketmon at, the first one would be 0, or yeah, it would be 0, and then 0, and then it would be just Pocketmon. So that's what it's doing under the hood. It's calling it like that every time, and then the second time, it calls it like this. Right? And then the third and final time, it will call it like that.
So, and because Pocketmon square bracket 0 is the first value, that gets substituted for str, and the
Yes.
rest just doesn't get.
Exactly.
It's discarded.
Totally. So the
Okay.
first argument is going to map to the first parameter.
Got it.
And since str, first parameter, str is now Pokemon at 0, which is Charizard.
Yeah. Okay.
Question is passing the function in the underscore map parameter the same as calling it?
So is it the same as calling it? So when you pass it to map, you aren't calling it, but map calls it for you. So yes and no. If you don't want this function to be called, then you shouldn't be passing it to map, because map will just, under the hood, it calls the function for you. Really similar to in our callback exercises where we took a function and then we called it immediately.
So isn't that one that you have highlighted? That's just a reference. So it's telling map this is where that function is. It's not
Yeah.
actually doing the function. But then when map does its internal things, it's
Right.
going to that address and saying, oh, here's the
Exactly.
function.
So map is its own function. So we're calling map, and somewhere in the underscore library, we're entering into the function body of map, right? And we have 2 arguments that we're giving to map. And map has some functionality that it does always with these 2 arguments. So inside the function body, it's going to loop through this list, and it's going to call this function with each value of the list. So as it loops, it's going to call it, and that's how it works under the hood. And we can even look at it if we wanted to map. So we see it takes an object, and it takes an iterator, and if we look somewhere in here, we see that it's calling the iterator function. So it's looping, first of all, right? You see that loop? And it's doing a little bit more than what I'm expressing, but the main point is that it's looping, right? And then it's calling that iterator function with the value, with the property, and with the entire object, right? And so that's what map is doing under the hood. Cool. Any questions on that? And the key thing here is we want to save this in a array. I'm sorry, in a variable because it's returning an array. So var, I don't know, excited, Pokemon equals this. So now we have transformed our array into an excited array.
Could you have saved it in your same Pokemon one to overwrite, and that should be okay?
Yep.